Dear students of class 7, last time we were doing mixtures. So mixtures are the substances in which two or more than two types of pure substances are mixed in any ratio in such a way that the components retain their properties. So mixtures, then I say mixtures are two types. Types of mixtures today we will be doing. So then characteristics of mixtures, and also I said components of mixtures, they retain their properties. They retain their properties. Yeah. So types of mixtures. Types of mixtures. Substances in different states of matter form different types of mixtures. So substances in different states of matter form different types of mixtures. So for example, states means say solid plus solid forms mixture. Solid plus liquid as well. So solid plus solid, sand and stone, or sand and salt. Then solid liquid, then liquid gas. Any different states of matter form different types of mixtures. Depending on the composition, mixture can be broadly classified into two groups: homogeneous mixtures and heterogeneous mixtures. So, depending upon the different states of matter, there are 9 types of mixtures. But broadly, these mixtures can be classified into two groups. They are homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures and heterogeneous mixtures. So let's see homogeneous mixture. So what is homogeneous mixture? Let's see homogeneous mixtures. The word homogeneous means that the components are uniformly mixed. Mind you, this is very much important word point here in this definition. Uniformly means it is distributed throughout the whole volume, okay, equally. So uniformly mixed, or they have the same properties throughout. So what are homogeneous mixtures? Homogeneous mixtures are those mixtures in which components are uniformly mixed. So, or you can say they have the same properties throughout. For example, salt solution. Take a spoon of salt and a glass of water. Put this spoon of salt in that glass of water and start stirring, dissolving it. Then when all the salt is dissolved, when no more particles can be seen at the bottom, then you can say that mixture is homogeneous mixture. Means all solutions are homogeneous mixtures. Okay, so homogeneous mixtures. Now, if you take 1 spoon of solution, salt water, and taste it, it will be salty. If you take 1 spoon from the middle of the glass, then also it is salty. If you take from the bottom of the glass, then also it will be salty. Means they have the same properties throughout. For example, alloys. Do you know alloys? Alloys are homogeneous mixture of solid homogeneous mixture of metals with other metals or maybe non-metals. For example, brass, bronze, solder. These are alloys, and we use this brass and bronze. This brass and bronze is used. Bronze, you know about bronze medal, and also this bronze is made up of copper and tin. Okay, so alloys. Solution of sugar in water and milk. Solution of common salt in water. Just now I said cough syrup, honey, etc. So these are all homogeneous mixtures. So all alloys are homogeneous mixtures. Solution of sugar in water and milk. If you mix water and milk, then also they will mix uniformly. Then solution of common salt in water, then cough syrup, honey, etc. If you make solution of sugar in water, the sugar molecules get uniformly distributed among the water molecules and make the water sweet. So after dissolving sugar in water, if you wish to take 1 spoon of water from the bottom, it will be sweet. 1 from the middle, it will be sweet. 1 from the top most, then also it will be sweet. That means sugar is uniformly mixed in water. So it forms homogeneous mixtures. Homogeneous means uniformly mixed, in which the components are uniformly mixed. Blood is also homogeneous mixture. Blood is also homogeneous mixture. And again, air, you are very much familiar with the word air. Without which we cannot survive. So air is also homogeneous mixture of many gases. There are many gases in air, but then also they are uniformly mixed. They are uniformly mixed. So air is homogeneous mixture. Okay. Then this is mixture of alcohol and water. Mixture of alcohol and water. So if you mix alcohol in water, they will mix uniformly. They will form single layer. They will form single layer. If you mix mustard oil in water, can they mix uniformly? No, they cannot mix uniformly. They form different layers. They form different layers. Mustard oil will be on the upper layer, and in the bottom layer there will be water, because mustard oil is lighter than water. So alcohol in water is homogeneous mixture. Homogeneous mixture. Liquid homogeneous mixture. Okay. Then let's see heterogeneous mixtures. Heterogeneous means that the components do not have the same properties or characteristics throughout. So here in heterogeneous mixtures, components do not mix uniformly. Components do not mix uniformly. Okay, so do not have the same properties or characteristics throughout. For example, if you mix sand and salt like this randomly, then somewhere you can see the salt will be more and somewhere the sand. And the same way, small pebbles in pulses, they are also not uniformly mixed. And while making omelette, if you put salt like this, then after while eating you will come to know that some portion it has a lot of salt, some portion it is tasteless, saltless, it is not salty. That means that is also heterogeneous mixture, because the components are not uniformly mixed throughout the bulk. So for example, sand and salt, water and kerosene, they form different layers. Kerosene comes up, kerosene occupies the upper layer, and water will be in the lower layer. So they will be forming two layers. And chalk powder and water, chalk is insoluble in water. If you try dissolving chalk in water, it will not dissolve. So all the chalk particles comes down, settles down. Similarly, chalk powder when mixed in water settles down at the bottom of the beaker. The following table gives some examples of homogeneous and heterogeneous. Okay. So this is mixture of oil in water. You can see oil. This is oil. It is not uniformly mixed. It is concentrated over here only. So they will not mix uniformly. They form different layers. Okay? Then some common examples of homogeneous and heterogeneous mixtures. So mixture, type of mixture. Solid plus solid. One component is solid and the other component is also solid. So solid plus solid. And type of mixture. So these are the states, and on the basis of state, solid, solid. So iron is solid. Solid iron plus sulfur is also solid. When you mix, they form heterogeneous mixture. So why they form heterogeneous mixture? Because if you bring magnet nearby these, then iron particles will get attracted. Means they are not uniformly mixed. They are not uniformly mixed. So it forms heterogeneous mixture. Sand and sulfur. Sand and sulfur, if you mix, then also they will not get mixed uniformly. So it also forms heterogeneous mixture. Then gunpowder. Gunpowder is a mixture which is used for, it is explosive. It is explosive. So gunpowder is also heterogeneous mixture. Then brass. Brass is alloy of copper and zinc. Brass is mixture of copper and zinc. So brass, homogeneous. Bronze is also homogeneous mixture. They are uniformly mixed. They are uniformly mixed. Then solid plus liquid mixture. One component is solid, other component is liquid. Sugar, solid, liquid, water. If you mix, then it forms homogeneous mixture because it is uniformly mixed. Salt plus water also forms homogeneous mixture. Then glucose powder is solid and water is liquid. When you mix, they form homogeneous mixture. Then sand and water. Sand do not dissolve in water, it settles at the bottom. So it forms heterogeneous mixture because it is not uniformly mixed. Then rice and water. Rice and water, if you mix rice and water, then rice do not mix in water uniformly, means it cannot dissolve. So rice settles down. That means it is not uniformly mixed. That means it is also heterogeneous mixture. And then liquid plus liquid. One component is liquid and the other is also liquid. So alcohol plus water. Alcohol, when you add alcohol in water, it mixed uniformly, so forms homogeneous mixture. Petrol and kerosene. Petrol and kerosene. Mind you one thing, kerosene do not dissolve in water. Petrol do not dissolve in water. They form different layers. But if you mix petrol and kerosene, they form homogeneous mixture. They form homogeneous mixture. So homogeneous. Then milk and water also forms homogeneous mixture. Oil and water, they form different layers, they cannot mix. So it forms heterogeneous mixture, they cannot mix uniformly. Petrol and water also cannot form homogeneous mixture. They form different layers, they cannot mix uniformly, so they form heterogeneous mixture. Then gas plus liquid, sulfur dioxide plus water. Sulfur dioxide is gas and liquid water. So when you dissolve sulfur dioxide in water, sulfur dioxide do not dissolve in water. So it forms heterogeneous mixture. Then ammonia and water. Ammonia is highly soluble in water. When you pass ammonia gas in water, it mixes uniformly. So it forms homogeneous mixture. Carbon dioxide plus water, homogeneous. For this we are using in our daily life. All of you like to have soft drinks in this summer. Soft drinks. So these soft drinks, whenever you open this bottle of Coca-Cola or Pepsi or Thums Up, whatever, means gases comes up. You can see the bubbles coming up. Gases coming up. So these gases are carbon dioxide, which was dissolved in water. Under high pressure and low temperature, gases dissolves in water. So carbon dioxide dissolves in water, okay, and when you release the pressure, these gases comes out. So carbon dioxide can mix in water uniformly, so it forms homogeneous mixture. Then chlorine plus water. Water that comes from this one, PHE. Okay, they chlorinate water in the tank. They chlorinate, they put chlorine gas in water, and this chlorine gas mixes, dissolves in water uniformly, forming homogeneous mixture. Then gas plus gas. One component is gas and another component is also gas. So for example, air, oxygen gas, nitrogen gas, carbon dioxide gas, water vapors, then all inert gases are also there. So they mix uniformly to form homogeneous mixture. So air is a homogeneous mixture of gas and gas. Carbon dioxide plus nitrogen. So carbon dioxide and nitrogen are also mixed. Here air only you can take. You cannot separate carbon dioxide and nitrogen from air because they are not mixed. Like they are not heterogeneously mixed. Okay, so they are uniformly mixed. We cannot separate. Then ammonia and hydrogen. This is also homogeneous mixture. Then sulfur dioxide and ammonia. This is also homogeneous. Then chlorine and hydrogen also is a homogeneous mixture. So these are all the homogeneous mixture of gas and gas. Homogeneous mixture of gas and gas. That means gas can uniformly mix with another gas. So there is no heterogeneous mixture from gas and gas. Then differences between mixtures and compounds. Now last time only we did compounds. Yes. Then let's see what are the differences between mixtures and compounds on the basis of composition. Composition means how they are formed, with what matter they are made up of, how they are mixed, how they are combined. So this is all about composition. They are made up of elements or compounds or both in any proportion. So how are mixtures made? Mixtures are made up of elements, any pure substances. Either it can be element, for example, in case of brass and bronze, copper, zinc is mixed. Yes? So they are made up of elements or compounds. Elements or elements and compounds or compounds. For example, water is a compound and sugar is another compound. When you mix in any proportion, there is no fixed proportion. In any proportion, you can add 1 spoon of sugar to water, a glass of water, or you can add 2 spoons of sugar to a glass of water. But then also you will get mixture that is sugar water. So any proportion, this is very much important. Any proportion, there is no fixed proportion in mixtures. But compounds, they are made up of atoms of 2 or more elements in a fixed proportion. So how compounds are formed? Compounds are formed by mixing 2 elements also, by mixing elements and compounds also, by mixing compounds and compounds also. But what is very much important? Fixed proportion. Here, any proportion. If you mix in any proportion, you will get mixture. If you mix in a fixed proportion, you will get compound. Then nature, they may be homogeneous or heterogeneous. Mixtures can be heterogeneous or homogeneous. Heterogeneous means you can see with your naked eyes the components. But here you cannot see the mixtures, the components with your naked eyes. So they are uniformly mixed. So compounds, they are always homogeneous. Compounds can never be heterogeneous. Then appearance. Constituent substances do not undergo chemical change. Here, whenever we are forming mixtures, whenever we are making mixtures, no chemical change takes place. No chemical change takes place. That means when you dissolve sugar in water, chemical change do not take place. That is physical change, because we can get sugar back. So that is a reversible change. That is reversible change. So no new substance is formed, and they retain their properties. Sugar retains its property and water retains its property. So do not undergo chemical change. Also, they may or may not be evenly distributed, so they may or may not be seen separately. they may be evenly distributed, they may not be evenly distributed. If they are evenly distributed, homogeneous. If they are not evenly distributed, heterogeneous. That means they may be seen separately, they may not be seen separately. If they are seen separately, that is heterogeneous mixture, because for example, small pebbles in pulses can be seen through our eyes. That means they can be seen separately, so it forms heterogeneous mixture. And sugar dissolved in water cannot be seen separately, so it forms homogeneous mixture. But here constituent substances undergo a chemical change and cannot be seen separately. Here they cannot be seen separately. In water you cannot see hydrogen and oxygen separately. You cannot see. Then property. Constituent substances retain their individual properties. Just now I said you. In mixture, components never lose their property. Never lose their property. Okay? So, if you mix sugar in water, sugar will be sweet only. It will, when you dissolve in water, then also it is sweet. If you do not dissolve in water, then also it is sweet. Sweet means it has not lost its property. But here, once you combine elements to form compound, they will completely lose their property. For example, hydrogen gas can burn. It is a highly inflammable gas. Hydrogen gas can burn. Oxygen gas can help in burning. But once you mix them in the ratio of 1:8 by weight, then you can see that water, the product form, the compound form, that is water, it neither burns nor helps in burning. Means in compound, components will completely lose their properties, but in mixtures they retain their properties. Then separation, components can be separated by physical means. Constituent elements can be separated by chemical means only. If you want to separate hydrogen and oxygen from water, you need to use chemical process. But here it can be, here sugar and water can be separated very easily by physical means. Then energy change, no energy change takes place in mixture, but here energy is either absorbed or released. Energy is either absorbed or released. Okay, so this much for today. Hope you are seeing the videos and I am doing the test that is associated with the video. So hope you are very much safe at home and giving your time for studies also. So stay safe, give time for studies, help your parents. This much for today. Thank you.